All right, so I'll let you read most of this, but what I do want to point out to you is that when's an identity an identity? Well, what happens is this side is always equal to this side, and we could substitute. We could substitute in some numbers and see that it works. They talk about that. But what you really want to do, is make one side look like the other side without moving anything across the equal sign. I guess what we could do, what I'm seeing here is we can work on both sides. Generally, I only try to work on one side, but because this is kind of an algebra, not trig, but I see I can combine like terms on the left, so that becomes x plus 3. And on the right-hand side, I see 2x minus x is 1x, and then plus 3. So there we go. That's exactly the same thing. And we can do that, and that'll work for any number. I can take any value of x as it says and substitute it, and it would always be true. So then they give us all these identities, and these are all things, you should really try to jog someplace in your brain. These definitely. There's a couple of things we can do to make it a little easier. These are the same. Sine and cosecant are reciprocals. You probably know that already. But S goes with C. When you come to tangent and cotangent, yeah, those are reciprocals. But you also want to think about this, because sometimes when you're working with trig identities, it's easier to rewrite everything in terms of sine and cosine, because they're easy. You see how this just the reciprocal of that? Here's sine over cosine. This is cosine over sine. Or the other thing, in case you're slipping, if I have a triangle, and here's my angle. That's the angle I'm interested in. This is the opposite side. This is the adjacent side, and that's the hypotenuse. Well, if we're on the unit circle, we can say if this is the angle, this is the 1, and this is actually the y-coordinate, and this is the x-coordinate. And we can also think of this as, and this is going back to that unit circle work you did earlier, we know that cosine is the x, so the cosine of the angle is the x-coordinate right there. That's on the unit circle, right? If we draw a circle on xy axis, right? So that's cosine sine. That's all why it goes back to there. And that's why tangent is sine over cosine. Cotangent is cosine over sine. Okay, and then of course they get these cofunction identities, and these are related to the graphs of functions. The cosine is just the sine function shifted left or right, and there's a reflection going on there too. But we won't. That isn't what this lesson's about, and I don't want to go there and confuse you any further here. Okay, so this first exercise in the lesson, they're asking us to use identities to answer this following question. Well, we know it's in quadrant 1, and we could honestly, let's talk about doing this without identities. I know that this triangle is right here in quadrant 1. I know that angle. I don't know what angle that is, but I do know, and I know it's on the unit circle. That's 1, and that's root 3 over 2. And they're asking me to find all the other trig functions. So this is the x-coordinate. So how do we find that x-coordinate? Well, isn't this a right triangle? So x squared plus square root of 3 over 2 squared has to equal 1 squared. And if you want to think about this, they did tell us to use identities. We know that cosine is x, so we know that cosine squared plus sine squared, and I'm just going to rewrite this because that's the way I usually write it, as sine squared plus cosine squared, but I'm going to rewrite it this way: sine squared equals 1. That's the identity that's up. I don't know if I can scroll up to it. Let's see if I can scroll up to it here. That's on the other page. But that's one of those Pythagorean identities. So to make this exercise happy, well, let's do it without the identities, and we'll make the exercise happy, all right? So if I square, so x squared is x squared, and we know root 3 over 2 squared is 3 over 4, and that equals 1, right? And you're okay with y is 3 over 4 because it's square root of 3 over 2 times square root of 3 over 2. Root 3 times root 3 is 3, and 2 times 2 is 4. And then we'll subtract we'll subtract the 3/4, which is 1/4, and we take the square root of that. Square root of 1 is 1, square root of 4 is 2, so x equals 1/2. So that's 1/2. Okay, and you could have done that. We could have done that without the identity, but though we were using it, we just weren't going at it formally. Okay, so then what are all the rest of the identities? What are all the rest of the trig functions? Well, I know that we know sine. We know sine is √3/2. We know cosine is x, which is 1/2 in this case. We know tangent is y/x. So, boy, it'd be nice if I had a blank paper here. Just a minute here. If I can see if I can slide this over. Oh, good. So we know tangent is y/x, or sine over cosine. So √3/2 divided by 1/2. Well, isn't that the same as √3/2 times 2/1? Remember, when you're dividing fractions, you take the reciprocal of the divisor, sorry, and make change the multiplication. Well, there the 2's cancel out, right? So the tangent's √3. Then let's do the reciprocals. Well, we know that cosecant is a reciprocal of the sine. So if the sine is √3/2, that becomes 2 over the square root of 3. And we could rationalize that. Sometimes we want to rationalize it. So I'm going to multiply by √3/√3. So 2 square roots of 3/3. This is perfectly acceptable too. And sometimes that's more useful. So that's the cosecant. We know the secant is a reciprocal of the cosine. Well, if the cosine's 1/2, the reciprocal is 2. And we know cotangent is a reciprocal of the tangent. So if the tangent is, where did I write tangent? √3. So if tangent's √3, 1/√3 is the cotangent. And again, if they want to rationalize it, if it's a multiple choice question and they rationalize it, you got to be able to do that. Okay? So that's that first example. Hopefully that went well for you, and you can see how that worked. Okay, for this next example, we want to show that this side is equal to this side. And what I usually do when I have to verify trig identities, I'll go with a more complicated side and try to simplify it. Sometimes that doesn't work, and it takes more effort. One thing I'm noticing right here on the left-hand side, I see I've got sine and cosine. Why don't I rewrite that tangent in terms of sine and cosine? So sine theta over cosine theta, because that's one of the identities we knew, right? From up above, or you maybe knew that anyways. So this is the fraction, which means divide. So sine theta cosine theta over 1 times, here, let's see if I can erase this little piece here. No, it's not going to let me. Times, so I'm going to multiply that as cosine theta over sine theta. And then I see the signs of multiplying fractions, so I can do this cross-canceling simplification, right? So that leaves cosine times cosine, which is cosine squared, and that's what we wanted to show. So it's that easy. They get more complicated, and you can do a lot more with this, but that's the process. Notice how I only worked on one side. I didn't multiply across the equal sign. I didn't add or subtract across the equal sign. That's an equation, not an identity. We're trying to show that one side equals the other. Then they're telling us to factor this. Well, what you can do is you can think of, if having the sign in there is confusing, let's do this little substitution. Let's say u equals sine of x. So I'm going to rewrite this as 3u squared minus 5u equals, minus 2 equals 0. Let's see here. Minus 2 equals 0. Well, actually, we don't want to have to equal 0. It's not an equation. I'm introducing that. I have to factor that. Well, if you just think about, I don't know how you've learned to factor. I know that 3u times 1u is 3u squared. And I know that 2 times 1 is 2. So then I just got to try substituting in some numbers. Well, this is 6, and that's 1, and 6 minus 1 is 5. So it looks like I set the numbers in the right place. I want the 5 negative in the middle, so I want the 2 times 3 to make a -6. And that's factored. Now we just got to do the back substitution of get it back to a trig expression. So 3 sine x plus 1 is one factor. The other factor is sine x minus 2. And we're done. It is an equation. They aren't asking us to do anything else. Okay. Okay, for this last one, they're telling us to substitute in 4 tan x for the x. So I'm going to write this 16 plus 4 tan, oh heck, it's in here, I can't write. Tan x squared, and that's all under the square root. And then we've got 16, well, let's see, 4 squared is 16, and tan squared, we'll just write as tan squared x. And that's still underneath the square root. And I see I can factor 16 out of everything. And because this is the product, I can treat these things separately. So then, square root of 16 is 4. This is kind of messy. So then what you want to think about, right, this is kind of messy. So if you think about, if you look back at that table of trig identities, you're going to see that 1 plus tan squared x, or u, equals secant squared. So we can do that substitution. We know that 1 plus tan squared is the same as secant squared. So the square root of secant squared, x, u, whatever. And then remember, this is still all under 1. So then, let's see if I can't move this up a little bit. Move it off to one side. So that's going to leave me 1 over 4. Now the square root of secant squared is secant, right? The square root of anything squared is the value. And then secant's the reciprocal of the cosine. And I am taking the reciprocal, so I'm going to rewrite that as cosine x over 4. And I believe that's the right answer. You could write it as 1/4 cosine x. And that's that simple. Okay? Now, what I really recommend you do, and I mean, as always, you should go do, get that copy, open up that copy of the PDF from the textbook that you got at the beginning of the course, do those practice problems. You're going to see my answers. All my work to these are in the top of the module. So go do those. This is wicked important for you to be successful. I mean, people try to cut corners by not doing those, but you want to do those. Alrighty, I'm going to upload this and send it to you.